Just a reminder to slow my speed down. 1.5 is a good number. All right, here we're going to talk about the properties of the real numbers. Remember, everything is a real number in algebra, so it's all those numbers that we just talked about. I know this is not the first or the second or probably not even the third time you've seen it. You've seen this, but sometimes students forget how to classify those properties. So we're going to review it, and it should be a refresher for you. So let's take a look at the commutative property. So the commutative property is where the order of values does not matter. So I know you've heard it. I know you've seen it. So for an example, if I said, what is 5 plus 3? We know that it's 8. I also know that 3 plus 5 is equal to 8. So the order in which I added doesn't matter. That is the commutative property. This is the commutative property of addition. And we also have the commutative property of multiplication. So if I said 3 times 5, I would get 15. And if I said 5 times 3, I would get 15. And that's the commutative property of multiplication. Now, what about if I did 5 minus 3, is that equal to 3 minus 5? Because equality is the key here. 8 equals 8. 15 equals 15. But can I do 5 minus 3 is 3 minus 5? No, because there's no equality. That would be 2 equals negative 3. Those are not equal. That is not the commutative property. Notice it only works with multiplication and addition. However, if you look at this, negative 5 plus 3 is equal to negative 2. What if I did 3 minus 5? Is that equal to negative 2? It is. So this is the commutative property because those signs changed with it. This is a positive 3, this is a positive 3, a negative 5, and a negative 5. So be careful. Equality is what we're looking for here. All right, that's the commutative property. Let's take a look at the associative property. How do I toggle up? All right, the associative property is when the grouping of values does not matter. So all that means is the grouping. So when we look at grouping, if I had 1 plus 3 plus 5, is that the same as 1 plus 3 plus 5 and I changed my group? Yeah, because if I did it, I would get 4 plus 5, and that's 9. And over here, I would get 1 plus 8, which is also 9. So look, the order stayed the same. Not commutative, order stayed the same. But the grouping, my parentheses, went from 1 plus 5 to 3 plus 5. So that grouping moved, and it still is equality. Okay? So that's the associative property. That's the associative property of addition. We also have the associative property of multiplication. Now look, let's change this to 6. Or no, let's change it to 7. 7's good. All right. So if I did 35 times 2, that is 70. Over here, sometimes it's easier to do 5 times 2 to get that 10 right off, and then multiply it by 7 to give you 70. So if you're familiar with your properties, you can make it work for you. I know I used a number like 2, but I would much rather start multiplying to get 10 rather than to work with a number like 35. Okay? So that's the associative property of multiplication. All right, but equality is your key. The identity property just means the value stays the same. It doesn't change. So your identity property stays the same, whether you're adding or multiplying. So, what would I have to add to 5 to get it to equal 5? 5 plus what equals 5? 0. That is identity. Whatever you start with, you end with. Multiplication. 7. What do I have to multiply by 7 to get 7? Identity. What you start with, what you end with. What do I have to multiply to get 7? 7 times 1. So this is the identity property. Caution, caution, caution. This is not property of 0. Just because you see a 0 does not mean it is a property rule, okay? This is identity, whatever starts and stays the same, okay? All right, what about that inverse property? Inverse property is what we use all year long in 1- and 2-step equations. It just means you're using the opposite to cancel out a value. So, for instance, it makes more sense when you do a 2-step equation. In a 2-step equation, if I solve for x, I have to get rid of that positive 5. How do you cancel it out and get rid of? You do the opposite. So if it's a positive 5, we subtract 5 on both sides. Ding, 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 ding. This is the inverse property. Canceling it out. 5 minus 5. So an example could be 5 minus 5 equals 0. It's better seen in a 2-step equation. So now I'm here. How do I get this x value to be 1? Because when we're solving an equation, we just want x to be 1. Well, you multiply by the reciprocal, 3 over 1. And whatever you do to one side, you do to the other side. This is the inverse property of multiplication. You're canceling out to make it equal 1. So I could do 1/3 times 3 over 1 equals 1. And you will hear me say these two properties all year long. Inverse property. All right, here's that property of 0, not to be confused with the identity property. Property of 0 means, well, let's look at the word of. In math, of means multiplication. So multiply by 0, what do we know happens? Anything times 0 always equals 0. Always. So 5 times 0 is 0. 1,000,000 times 0 is 0. Property of 0. Of means multiplication. All right, distributive. I think distributive is probably most teachers' favorite. It's where you are distributing, you are multiplying a value, to an expression inside parentheses. You evenly distribute, right? You evenly distribute. So if my mother told me to get 5 apples one week and 3 apples the next week, that's going to give me 8 apples, right? But if I repeat this pattern for 3 weeks to get 5 apples and 3 apples, well, I'm distributing 3 weeks. So I got 5 apples here, which was 15. And in 3 weeks, I got 9 here. So 15 plus 9 is 24. You distribute this value equally inside that parentheses. That was probably a terrible example. So let's do this. If you have apples and 3 bananas, okay? So for 5 weeks, so in 1 week, my mom wants me to pick up at the grocery store 1 apple and 3 bananas. Well, at the end of 5 weeks, I would have 5 apples and I would have 15 bananas. You distribute equally inside those parentheses. That's the distributive property. This year, we have 3 new properties. So, looking further down, we have reflexive, symmetric, and transitive. You may have looked at them last year, but they might be brand new. So, what's reflexive property? This is almost too easy to be a property, okay? It almost is too easy. It is where a value always equals itself. What? Yes, it is the exact same thing on both sides. It is 5 equals 5. It is 3x equals 3x. It is x plus 2 equals x plus 2. Notice I'm not changing the order. That would be commutative. It is exactly the same on both sides. Why we learn it in algebra and not geometry? I don't know. But you will use this a lot in geometry. So just reflexive property, exact same thing on both sides. Now, I want you to highlight this next one, the symmetric property, because the symmetric property is my favorite. So highlight that puppy. My favorite is symmetric. Symmetric property, if you want the rule, is just if A equals B, then B equals A. Okay. Here's one thing you need to know about me, always. Do not tell me that 5 equals X when you solve a 2 or 3 step equation. That's true, 5 can equal X, but I'm old school. I want my variable on the left-hand side and my value on the right-hand side. So let's say you solve this equation, 5 equals 2 plus X, and you subtract 2 on both sides and you get 3 equals X. That's a true statement, but that drives me crazy. I want X to equal 3. So what do? I apply that symmetric property. I'm not doing anything but moving X to the other side and 3 to the other side. It's the same thing. That's symmetric. It's moving to the other side of the equal sign. It's not multiplying, so I'm not changing positions. I'm literally moving across that equal sign. That's the symmetric property. Transitive property, again, this is used a lot in geometry, not so much in algebra, so I don't really hit on it that much, but you do need to see it. And that says if A equals B and B equals C, then A equals C. So, for instance, if 4 plus 3 equals 7, and 7 equals the square root of 49, then 4 plus 3 equals the square root of 49. So look what happens. I'm repeating this value. If I changed it and I said, okay, here's the first part, here's the second part to the third part, I'm canceling out that middleman and going straight from A to C. So it sounds a little tricky and it sounds a little confusing, so here's how you can remember it. Transitive has 3 different parts. So does the transitive property. You have A, B, and C. And all it means is if these values are the same, you can cancel them out and make A equal to C. So those are the properties that we're learning this year. The closure property we are not learning, so you can cross that out.